some problems. We're going to do number 3 from the assignment. It says negative 3p minus 5q. So you go negative 3, p is negative 1, negative 2, 4, and then minus 5q, which is 6, 1, 2. Now you can do this a couple of different ways. The way I like to do it is I like to, in one shot, do this. So this is negative 3 times negative 1 is 3 minus 30. Then this is negative 3 times negative 2 is 6 minus 5. And then this is negative 12 minus 10. So can you see how this is kind of nice to do it in one? Negative 27, negative 1, negative 22. Or, if you wanted to, if you don't like that method, you can do it in two bits here. You can do 3, 6, negative 12, plus negative 30, negative 5, negative 10. Now you can see it's 3 minus 30 is negative 27, 6 minus 5 is 1, and negative 12 minus 10 is negative 22. I think I said negative 1 before. It's positive. Next. 6, sure. Is that down below here? Oh, it's later. Okay. Sure. 2, 6. Find the maximum speed of a particle whose velocity is v meters per second at time given by. Okay. So, what do you think? Maximum speed. Will, what do you think? Do you think it would work to take just the derivative of this? Probably not, because what we need here is the magnitude of it first. So the magnitude is the square root of 4 sine squared t plus cosine squared t plus 9, right? And then the maximum speed of that is, I think you're going to set that derivative of that equal to 0. Does that sound right? So if we take the derivative, 1/2 4 sine squared t plus cosine squared t plus 9. Derivative of the inside is going to be 8 sine t times cosine t minus sine t plus 0 equals 0. And you're going to have one of these are going to be, one of those are going to be equal to 0, or both of them can be 0, but one of them for sure is going to have to be 0. Let's try this one. 8 sine t cosine t equals sine t. And so I think you could divide by sine. What we probably should do instead, let's do it this way. 8 sine t times cosine t minus sine t equals 0. Take out a sine t, and you're going to get 8 cosine t minus 1 equals 0. So sine t could be equal to 0, or 8 cosine t minus 1 equals 0, which I think is just going to be cosine t equal 1/8. What did they say the answer was? Square root of what? The square root of 13. Forget about what I just said. You don't need to do any of that. All you have to do, you ready? All you have to do is say, okay, you're going to look at t greater than 0, right? Find the maximum speed. Well, the maximum speed is let's take my unit circle here. What's the biggest that sine can get? 1. Okay. What's the largest cosine can get? 1. So this coordinate is positive 1 comma 0. Do you agree with that? This coordinate is going to be 0, 1. Do you agree with that? So you will either have, are you okay with my magnitude thing here? You'll either have a this equal to 1 and this equal to 0, which would give me 0 plus 1 plus 9 is the square root of 10. Or, what's the other maximum thing we could have? We could put a 0 here and a 1 here, and now what do you get? Square root of 13. That's how they did it. That's kind of lame-o, but we just found the magnitude, and then we're going to, yeah. We found the magnitude, and this is the equation for magnitude. Sine and cosine only goes so high, so we pick those max values, and that's going to give us our max distance. And let's go to, we're good with these. Look at 4a, find a vector of length 3 units in the direction. So what you would do there is I minus j plus k. The magnitude of that vector is the square root of 1 plus 1 plus 1, right? Square root of 3. So this thing is the square root of 3 units long. So if we multiply it by 1 over the square root of 3, now how long is that vector? 1. So if you want to make it a length of 3, won't you just multiply it by 3? Those are good. Great. Let's see, we've got these magnitudes are good. Oh, this one? Sure. A submarine is considered the origin. It's 60 meters below the surface when it is detected, when it detects 2 surface ships. So it's at the origin, it goes down minus 60. And then it says a destroyer is 600 meters to the east and 800 meters to the south of the submarine. So it's 600 meters east, 600 meters east. This was minus 60 down below. And then where was the other one? It was south. Okay, so this one's going to be.
No, the destroyer is 600 meters east and
800. Oh, okay. So this one has, oh, all right. So we've got a little bit of, let's try it this way. Here's the way I like to do this. So we're east 600 and then south 800. So this is 600 and this is 800. I bet you could find this distance. There's one destroyer. And then an aircraft is 1,200 meters west. Oh, aren't these fun? They're so fun. 1,200 meters west, and then 300 south. And I bet we could find that distance, couldn't we? And that one is my aircraft. Okay, and all right. So here's what I would do. I would make 3 vectors. This vector is going to be back 600. It's going to be south will be back 800. And how deep is this destroyer? Is it underwater?
It's
Surface. Okay. This is my destroyer vector. Now for the aircraft, we're going to go in the x direction. Wait, I think this is considered positive, east. This will be negative 1,200, and then it'll be 300 south again. That's negative. And then is it above or below the water? It's right at the surface too. So that's my aircraft. The sub is 0, 0, minus 60. Using the submarine as the origin, state the position. Okay, so now all that's going to happen here is we're going to shift this to 0, 0, 0. So then this one's going to shift to 600, negative 800, and then this is going to be what? 60 above. And then this one's going to shift to negative 1,200, negative 300, and 60. Okay, helicopter pilot based on the aircraft carrier wants to make supply delivery to the destroyer. Find in vector terms the course along which the pilot should fly. So the pilot's going from the aircraft carrier to the destroyer. So find in vector terms the course. So the aircraft is at, should we use, which one? Doesn't say. So let's just go negative 1,200, negative 300, 0, and the destroyer, right? We're going to the destroyer, and that's just at 600 and negative 800 and 0. And we want to know how far they're going to have to go, how far it is from D to A. So I just subtract them. So you're just going to get negative 1,800. No?
traveling to the east, which because you subtract A from D, because D is your destination, so it's going to be ahead of
Oh, you could, sure. Sure. So we can put those, we could do, add the opposite of there. So then, yeah, then it'll be positive distances for X, which will be 1,800 meters, which they have to go. Negative 1,800, this will be negative 500, and then that'll be 0. I like it, D minus A.